Dear student, in this video lecture, in connection with the previous video, I will demonstrate how linear and non-linear regression can be done. Okay. For that, I have given the code at the bottom of the manual. First, let us import the necessary libraries. Import numpy as np. Import Matplotlib.pyplot as plt, and next let us import the necessary library for the linear regression. Import scikit-learn dot model linear underscore model. Import linear regression. Import. This library is necessary for fitting non-linear equations. So, okay, from here it should be from here it should be from SciPy dot optimize. Import curve underscore fit. Yeah, the necessary libraries are imported. Now let me give my x value, that is, let me give it within the list. Okay, 1 comma 2 comma 3 comma 4 comma 5. Now my y value equal to, in our manual it is given as 2 4 2 4 comma 5 7 9 comma 7 9. Okay, and let me check. No issue with the extra space. Again, let me run it again. Here I will convert this list into array. Okay, why? Let me explain in simple words. Suppose I am going to do a mathematical operation x multiplied by 2. You can check whenever I am going to do any mathematical operation in list, it is very difficult to do it. Shift enter. You can notice that the x list is repeated multiple times. That means list is the operator where we can use the numbers as well as the characters. Suppose I can even use here hi. That will not throw any error. Okay, and if you do that, same thing again will be repeated again. Okay, especially whenever you're going to use scikit-learn library, we need to give the input in terms of array. Okay, what is the array? Okay, now I'll just import. Now I'll go to the next line. Now I want to convert my x value into array. Okay, for that np dot array, within a bracket give the list, that is x, and again let me do it for the y also. np dot array y. Okay, now these elements are converted into array. Okay, now let me check the shape of the array which is newly created, x dot shape. Okay, and it is a one-dimensional array. Similarly, I can do it for the y also. y dot shape. Okay, this is also one-dimensional array, and generally scikit-learn library expert x value need to be given as two-dimensional. For that, I need to convert. We no need to worry about y. Here I need to convert x value into two-dimensional. For that, I will give you a new way of reshaping that. Okay, x equal to np is x dot reshape minus 1 1. What I'm conveying here is I'm instructing Python. I want one column. I'm not bothered about number of rows. Okay, so if I'm not bothered about number of rows, so you just give minus 1. That will arrange the column. Then depends on available data, it will rearrange the same. Okay, let me give shift enter. Now you just check x dot shape. Now the previous x, that it had a one dimensional, is now converted into the two dimensional. Now you can check here, I have been given only one column but 5 rows. Okay, this minus 1 indicate that depends on how much column instructed, you can rearrange such a way that I can have one column. Okay, that is the way we can reshape the given array. Once I have reshaped my list values, now I'll fit into the model. Okay, for that I need to create a instance of the class of linear regression. For that I need to write model equal to, here I'm creating instance of linear regression. So linear regression. Then once I create a linear regression instance, I can fit the data into the model. So model dot fit. I'm fitting my data x comma y. Yeah. Now let me run the code. Now I fitted my x and y values. Now next thing, I want to predict what is my y value for the fitted x and y data. So y underscore print equal to, what I have to do is model dot predict. Okay, previously to fit you called dot fit. To predict you have to call model dot predict. Then I have to give my x value as we done it in the Excel. Okay, if you remember to predict y value, I use the same x value. Same thing I'm doing in the my Python. Okay, shift enter. Now the values are predicted. Now what is the y predicted? Okay, let me check the value y underscore print. So these are the values are predicted. Now I want to plot the graph. Plot scatter x comma y label actual, and I want to give a marker as star symbol or star symbol. Okay, I can even give like like structure. Let me check here. So that is a plot we plotted here. So I have plotted the star using star symbol. Now I want to plot my x and y predicted. So x comma y underscore print comma label equal to predicted. I close the bracket, and if you want to even give the marker here, you can give the marker also here also. Marker here I want to give us O. Let me run the file. Yeah, you can check the O is the predictor, the star symbol is the actual value. Let me give the label for the x and y axis. plt dot x label x values plt dot y label y values and plt dot title predictor versus actual, or actual versus the predicted. Okay, close the bracket, and I want the legend to be displayed. And prior to giving the legend to be displayed, let me give the color for the each thing. Okay, color, I want red for the actual value, and color blue for the predictor value. Yeah, now legend also displayed here. And suppose if you want to display the what is the values of m and c, yeah, here we have calculated m and c value. What you can do is that is separately we can give here insert column, yeah, model, let me take print. Okay, print f double dash the slope of the equation. I want that is model underscore dot co f 0. I want that should be in the 2 decimal dot 2f, then close it and close the bracket. Yeah, prior to that, yeah, the intercept again model dot intercept. Let me check the code for that also, what I have given in the manual. Intercept, yeah, you have to give here, yeah, underscore here also, you have to give the underscore here, and close the code, and let me check whether this runs without error. Yeah, f double dash here, yeah, and you can observe. Okay, and here the value of m is given with the 2 decimal, but the value of intercept is given with the multiple fractions. Okay, for that let me again do it here. I'm instructing by Python. I'm going to give the format. What is the format? Dot. After the dot, I must have the 2 fractions. Okay, now check the values here. Yeah, it is given in the 2 intercept, and you can check with the Excel value also. Excel also, the slope is m equal to 1.6, that is approximately 1.7, and c value is 0.3. And if you compare here I'm not given that within the square bracket, I'm not given 0 because here I'm using only one independent variable and one dependent variable. Generally in the linear regression we may have the multiple independent variable. Okay, I'll just show with the paint. Generally the equation, I have the data like, okay, so x1, x2 and y. So like that, let me have even xn and y value. Okay, and I have like n number of independent variable, and the same thing can be fitted into the linear equation, that is y is equal to intercept plus a1 x1, a2, x2, like that we can have an, xn. So since in our case only we have one independent variable, I'm just calling only one slope, and also in our data only one slope. That's why we are writing model dot if I'm calling the first value, 0th value. Okay, and you can even check if you generally use this line. Okay, this line it will give within the list. Yeah, I will show you with the simple code. Okay, you can check. Yeah, it will give a array which have only one value. Suppose I'm going to use two independent variables, it will return with the two values. Okay, yeah. Now let us go to the non-linear regression. For that I'm going to use the curve fit. For that, first we need to create a function which equation I want to fit. Okay, to define function we have a syntax called def. Now I'm going to define a function. So let me define a function named as expo. Okay, and for that what I want to give as input, we look at our Excel. I want to give my, to predict y value I must give a, b and the x value. So here I am going to give x, capital X, or whatever value you can give, a comma b colon. Now give return that we're going to return. What is going to return? My function here, a star np dot exponential. So I'm using library called NumPy to use the mathematical function called exponential. Okay, and b multiplied by x. So b multiplied by x. Okay, and that will return. And you can, what is the advantage of it? Okay, now let me define x value. New x value, it is same as what we had. Okay, I don't need to worry about now. So now if we call expo, give x value as already we can define x comma a1 comma 1. I'm just giving input to the function named expo. Okay, shift enter, that will return the values of my y value. That is the purpose of writing function. Now ultimately means I want to fit the data for the x and y data as per what we have here. Now let me have, so y again, let me create a list first. 2.7 comma 7.4 comma 20.1 comma 54.6 comma 148.4. Here we can even keep it in list itself, or if you want you can convert them into array also. But let me make it uniform. I will just, if you're going to keep it as a list also, you'll get the answer. If you want to keep it in array also, you'll get the answer. Let me convert into the array. So y equal to np dot array of y. To convert x into one-dimensional array, I'm going to write x equal to x dot flatten. Yeah, now you can check the shape of x also. X. Now the shape of x is converted into the one-dimensional array. Now let me use the curve fit to find the values. Curve fit generally return two values. One is parameters. Parameter means the value of a and b, comma the covariance, which talks about how fit are my data, my model. Okay, covariance. Okay, that is equal to curve fit underscore fit. I want to give first the function expo comma x comma y. Let me run the code. Okay, now you can check the para will return two values. First one is the a value, second one is the b value, and we can compare with our Excel value also the a and the b value. Now the covariance. Okay, okay, the covariant, that is the values which the four values. I will not talk in detail about these, but lower those values my fit is very good. According to our data, our model, we have very lower value of a and covariance of a and covariance of ab, covariance of b, that is the a and b values is very less. That means my model is very good. Okay, now I want to plot the graph. Okay, for that let me again y underscore predict. Okay, that is equal to, again let me call the function my a value equal to para first value, zeroth value, sorry, a is zeroth value, and b equal to para 1. Shift enter, and you can check the a value. A value is the 1.009 and the b value is 0.99. So now I can call function again, my y underscore predict. Okay, and first I have to give the x value, that is I have to call the function expo. I have to give the x value, x comma, again I have to give a comma b, and that has given the y predictor. Now let me plot the graph. Again same thing, we can save the time by copy pasting the entire code. Only let us do the modification, the code. Okay, yeah. And xy actual marker red, y, let me give my new y predictor. Yeah, now shift enter, we have plotted the graph. And now let me plot only, yeah, scatter, you can check. This is the actual value. The moment I am going to plot the predictor, almost my all data are merged here. It means our model is very good for the given data. Thank you for watching the video.